Okay, so finally we will use the example to conclude this section on the query optimization. Here in this system, we have a relation employee. This employee has 4 attributes: SSN, name, salary, and phone number. And we don't show the table for the employee. Instead, we show a histogram distribution of the salary among all the tuples inside this employee table. So for the salary among all the employees, we can have different values. It can be a value which is less than 20K, or some value between 20K and 40K, or some value between 40K, 60K, 60K, 80K, 80K, 100K, and larger than 100K. And we'll show the number of tuples amount available for, in the employee table. The salary is in the range, in these different ranges. And we show the distribution in this page. The number of tuples, whose salary is between or below 20K is about 200 tuples. And this one is about 800 tuples. And we have about 500 tuples or employees whose salary is larger than 100K. So by summing them together, we know the number of tuples for the employee table is about 25K of tuples. And we also know the distribution now. Beside the employee table, we have another table. It is called ranks. This rank has 2 attributes. The first one is the rank name, and the second one is salary. And we didn't show the rank table either, and we also just show you the distribution of salary, this attribute inside the ranks table. All the tuples are also partitioned into different ranges as shown here, which will be similar for the above these ranges. And we also provide the distribution of tuples available in this range. For the salary, we have about 8 tuples whose salary is less than 20K, and we have 20 tuples in this range, 40 tuples in the range between 40 and 60K. 80 tuples between this range and 100 tuples between this range, and we only have 2 tuples whose salary is larger than 100K. Okay, so this is the data we can get. For this employee and ranks table, we didn't provide concrete or specific tuple results. Instead, we just provide you with a histogram distribution of different tuples on the salary attribute. Next, we will have a query, and we plan to estimate the size of some queries. And the query we are starting here is the employee joins ranks via the shared salary attributes, and we want to estimate the size of this result relation or the number of tuples available in the result relation. And we assume the V employee salary is 200, and we assume that the V rank salary is 250. It denotes for the employee table we have 200 different salary values. However, for the ranks table we have 250 different values for the salary attribute inside the rank table. Then we want to estimate the size of employee joins ranks via the salary attributes. It will be equal to what? It will be equal to the summation of I. I denotes the ranges we showed before, right? We have different ranges we showed before, and we enumerate all the ranges, and we also have the number of tuples available for both employee and rank tables in each ranges, which can be denoted by Ti and Ti prime. Ti denoting the number of tuples in the range, in the first range until the 6th range for the employee table. Ti prime denoting the number of tuples in the ranges for this ranks table. And we sum them together or divide by 250. 250 is the max of these 2 values. We have this V employee salary is 200, V rank salary is 250. This one is larger value, right? Because it will be divided here. And we evaluate all the ranges and also sum this Ti times Ti prime together, which can be denoted by 200 times 8 plus 800 times 20 until 500 times 2, right? Because this kinds of values denoting the specific tuple numbers in the specific ranges, right? For the first range, we have 208, which will be 200 times 8, right? And for the next range, it will be about 502, right? Therefore, we have 500 times 2. It will be divided by 250. And we can get the results, which will be the estimation of the result or the size of employee joins ranks via salary attributes. And you can try this example by yourself on your paper. So you can know, what will be the results we can get for the queries. Okay, so this is this section on the query optimization. I hope you can learn basic information about this, how we optimize the queries in the database systems, and how can we polish these queries into a better way via this dynamic programming algorithm. This section is very important, and we will cover this section in the final exam as well. So please make sure you can understand these materials and also understand this example we showed in slides. Okay, so that's it for this class and also for this section. We will move to a new section on data mining in the next week. Thanks for attention.